Good morning, everyone, and welcome to another edition of In Case You Missed It. This is a lesson recap for Friday, February 7th. Again, these recaps are mostly intended for people that are unable to attend the online class live, and it's also intended to provide a recap in case you missed something. So we talked about a couple of things. We started off with pseudocode. Then we went through this new document, exercise instructions, which has more detailed instructions for the first three exercises. So let's begin. Now, you have seen this before. Those of you that have taken um, uh, I just noticed I'm a little clipped here. I'm not recording my whole screen, trying to keep the file size of the video down, so a little bit of it's being clipped off here on the left. But we talked about pseudocode back in year 8, and you'll see references to JRU in these slides. But we have to distinguish between natural languages and computer languages. They are different, but they do have similarities, namely each has syntax and semantics, nuance, subtleties, etc. Now, with a natural language such as Chinese or English, there is an audience and a purpose. I mean, why do we speak and to whom do we speak? Well, the audience is another person. And the purpose is to transfer some thought from the speaker's mind to the listener's mind, or transfer some sentiment or emotion or something. But there's a transfer that happens from the speaker to the listener. Now, with a computer language, there are many, just like natural language. I think there are, 6,500 natural languages in the world. There are not nearly that many programming languages, but there are many. Can we say hundreds? I think so. And again, there's an audience. Sorry, guys, I have a loud cat. There is an audience and there's a purpose. Now, the audience, the immediate audience, is the machine. You, the programmer, are communicating to the machine. Ultimately, there's an end user that can benefit from the code you write, but your immediate audience is the machine. And the purpose is to give the machine instructions, to tell it what to do. The machine is very compliant, obedient, non-complaining robot that can do what you say and do it very quickly. But it doesn't get your meaning. If you say something incorrectly, namely if you give it poor instructions, it will either execute the wrong thing or won't execute at all. So there's no sense of humor in your audience. So your instructions have to be very precise. Now, how do we go from a set of instructions that you write to a program that the machine is executing? Let's put it this way. How do we go from the thoughts about the solution that you have as a programmer? You haven't written any code yet. You have some ideas about what the problem is. How do you go from there to source code? Well, the bridge between the two is called pseudocode. Pseudocode is a halfway point between the, let's see it here, pseudocode. Well, it's a combination of English and the target computer language, but it's a step that you take before writing code. A famous computer scientist once said, resist the urge to code. If you don't understand the problem, you're not ready to code. And one way to go from a halfway point from problem to source code is pseudocode. So it's a description of the solution that reads like English but looks like a program, in that it is formatted, indented, similar, formatted and indented, and yeah, from a distance it looks like a program, but when you get up close, it's a paragraph just restructured. So pseudocode is a notation to express an algorithm, and an algorithm is just a set of logical steps to solve some problem. A very simple algorithm example is the recipe to bake a cake. What are the steps you have to go through to bake the cake? So we start with a problem, we think of a solution, and then we express the logic of the solution. Those logical steps are the algorithm. Together they form the algorithm which you'll use to solve the problem. So again, you start with a problem, you formulate an algorithm, and you express the logic of that algorithm in pseudocode, and then you write the source code, or some other person writes the source code using your pseudocode. It's in this order always. Don't skip this step. Now, we'll talk about ways you can do this as well. So, lastly, or firstly, resist the urge to code. Now, that should be in quotation marks. I'll do it later. Yeah, I didn't come up with that. Someone else came up with it. So we have this. This was an exercise that we did back in year 8, and yeah, we have another exercise which I'll explain later. So we'll skip that. And this was the solution based on the pseudocode. Now, this was testing to see if a number is prime. We'll use the same problem in a few minutes, but this is how we solve that problem in Scratch. And we're not going to go through that right now. So let's go back to the lessons page. All right, there are a couple of videos which you can watch, and yeah, we will. I'll let you watch these at home. It sort of reinforces what we've just been talking about. The second one has to do with robotics, and the first one is pseudocode in general. Now, in the exercise instructions, I think I've put the example we're going to talk about. Yeah, there is the pseudocode. Now, this is what I want to talk about first. Now, unfortunately, yeah, I clipped it here. All the exercises are explained here. I suppose I can move this over a little bit so you can see it. Yeah, they're all there, and use this document for doing the exercises. So let's jump down to the pseudocode example. The following pseudocode expresses the logic of determining if a number is prime. Now, in the first class on Friday, we worked this out. Don't really have time to work it out from scratch, but let's just go through what we did. Now, there are a couple of ways to figure out if a number is prime. Sorry, guys, 1 second. Let me just. All right, I'm back. There's a couple of ways, couple of algorithms for determining if a number is prime. One of the students suggested get the square root and then divide by all the numbers between 2 and the square root. Yeah, that's one way. Another, the more brute force way, is explained here. So to see if a number is prime, divide the number n using the divisors 2 through n minus 1. If n is prime, if none of the divisors result in a remainder of 0. So this is sort of a statement of the problem in English and a very high-level description of the solution in English. So now we want to write it in pseudocode. And as you can see, the pseudocode is laid out like a program, but there is no strict syntax rules here. There are no strict syntax rules here. It's kind of free form. There are pseudocode notations that are very strict in the notation, but again, this is not going to be processed by a compiler. This is just intended. It's used by a software designer to then hand off to a software developer. So you can define or describe a bunch of variables up here. So this is the incoming number, this is what we'll divide by, and this is the remainder we're looking for. So we first prompt the user for a number, and then we capture that number from the user. The details of how to get the The input from the user, that's not important here. That will be determined or done by the programmer. Note that when you're writing the pseudocode, you don't know, or the designer doesn't know what, or doesn't necessarily know what the target language is. The developer might implement this logic in Java, or C, or COBOL, or Fortran, or a million other, well, 100 other languages. So this is an abstraction, and we're not concerned about the details of some language. So we get the number, and now here we want to divide that number by 2 through n minus 1 inclusive. Remember, recall that a prime number is anything that's divisible by 1 in itself, so we don't need to use 1 in itself. So we initialize the divisor to 2, and then we just start looping. Here's the beginning of the loop, here's the end, and we loop until the divisor is equal to n. We won't divide by n, but that's our trigger to break out of the loop. So okay, if you probably remember, maybe you remember this, modulo division yields the remainder. There are two kinds of division in computing. There's this integer division and modulo division. The integer division will just yield the quotient. So the answer to this is 2, whereas the answer to this is 1. 2 goes into 5 twice. We throw away the quotient. We just keep the remainder of 1. So we get the remainder. If the remainder is equal to 0, then we know that the number is not prime. So we display that and stop the program. If the remainder is not 0, we just come down and get the next divisor. So we increment the divisor by 1, and we go again. And we keep doing this until we either reach n or one of the divisors divides evenly, at which point we break out of the loop. So if the program reaches here, it means that none of the divisors resulted in 0, and we display that n is prime, and then we end the program. So that's a very simple example of how you would write pseudocode. Now, we have an even simpler way, which you will use, but you should be aware of this, because when we get to the design stage, when we get back to school, and when we get into the design stage, starting in March, you will be required to design parts of your robot, the hardware and the software, and you'll use pseudocode to design the software. For example, your challenge is to bounce off a block or negotiate around a block on a track. Well, how do you do that? What should you tell the program? What's the logic of that? Well, I hit the block. What do I do? Well, I have to back up. How far? And then what do I do? After I back up, I have to do what? Turn left, turn right. Okay, I make a turn. I make the turn, and then what? I have to go forward. All these things will have to be considered when you write your pseudocode. All right, let's go back to here. Now, still on pseudocode, this is a very simple example of pseudocode in the form of comments, which shows the flow or logic of the solution. You should begin like this before you write any code. Again, resist the urge to code. Now, this is very high-level pseudocode, but it's something. Now, everyone should be doing this. Remove that default comment that you get when you start a new project. Put the project name and some description of what the program does, and then include your name. And your teaching group over here, 921 or 923. Now, what is this program going to do? Well, it's at a very high level. It's going to display a triangle and display a square. That's it. So we try to make this as easy as possible for now. It'll get more complicated as we go. And then you would put your triangle display code in here and your square display code in here. The nice thing about this is you've already commented the code before you've written any code. Therefore, you're ensured that your code will include comments. Let's scroll down a bit. Now here is exercise 1 in more detail in case you haven't started this. So this is just spelling out again what we said in class and also what's in the lessons page. There's some instructions in the lessons page about how to do this exercise. Now, we did talk about the Hello World program in the first lesson. If you don't remember that, go back and watch the syntax video, C syntax video. But the hint here is you're going to use the same printf that was used in Hello World, and you're going to add in the tab character and the new line character. Tab character is going to push the shape over, so you begin each line of the triangle. And by line, I mean horizontal line. So you start with a tab, and then you place these characters in, and then you add a new line character. The next printf is going to have also have a tab, maybe followed by some spaces. Note this is one tab in. So this line is going to be a tab, excuse me, a tab plus a space. Maybe this is a tab plus 2 spaces to get this lined up. So you have to fiddle with this a little bit and try and produce that. Now here are some examples of the effect of using these escape sequences. The /t and the /n are 2 examples of escape sequences or special characters. Note these are characters just as much as the H and the E. They're just not visible on the page. Well, they're visible. You can see the effect. You just don't see a graphic representation. But I mean, this character is here instead of here because there's a tab here. Tabs are usually set up to be 4 spaces. So if I put 1 tab here, tabs in once. If I put 2 tabs here, it spaces in twice. Note down here that this is not nicely presented, but if we simply put a new line character here, then we get this thing to wrap around and it looks normal again. So I think this is fairly straightforward. Again, if you're not sure how to proceed, look again at the Hello World program. Now, the exercise 2 builds on exercise 1. It's okay to copy paste code from one exercise to the other. This is called working smart. It's one thing to work hard. It's even better to work smart. So you're going to name your project like so. In this exercise, you will display the same shape 5 times. So here we go. Here is the pseudocode. Give it to you. You can copy paste this into, well, this is an image. It's not editable text, so you'll have to type it. But here's the code. I'm going to display a triangle, then do it again, do it again, do it again, do it again. So you can take your code from exercise 1, just paste it in here. Again, fairly simple, but this is meant to make a point. Down here it says you can use your code from exercise 1. And that's how you can display this 5 times. Now, some food for thought. Think about what would happen if the requirement was to display the triangle 200 times, or 2,000 times, or 20,000 times, or 2 million times, 200,000, and so on. The solution that we're applying here does not scale and quickly breaks down. 1, it makes the program extremely long. 2, there's an enormous amount of duplicate code in it. And 3, if there's a problem down here in this display, well, that same problem exists here and here and here and 100 other times. So this is sort of a segue into the use of repetition, which you've seen before. You saw it in Scratch, you saw it in JRoo. Now you're going to see it in C. This is why we use looping constructs to make programs small, reduce duplicate code, and improve maintenance time. Yeah. So how does this approach break down as the number of shapes to be displayed increases? So that's fairly straightforward. The next exercise builds on exercise 3. So in this exercise, you'll improve the code from exercise 2 by using functions to organize your code and to eliminate duplicate code. This is, again, not a complete solution to the problem above. but another approach, another step in the right direction. So functions is part of it, looping is the other part of it. So in this exercise, you'll display all the shapes that you displayed in exercise 1. So a function is a block of code. Every block has a name. A function must be called in order for the code inside the function to run. So if you see line 19 in the pseudocode, again, here's the pseudocode for exercise 3, line 19, we are calling the function. So let's just go through the layout of this. Again, you have your documentation up here. We're going to create a function to display a triangle, a function to display a square, and then down here, we're going to call those two functions. Now remember, you're displaying the triangle 5 times. You're displaying the square 5 times. So you're going to have to make 10 function calls down here. So let's come back here. So you did this in year 8 when you created custom methods. Okay, they were called actions, but it was a funny language. The documentation calls them actions, but when you code them, they're called methods. So you created custom methods and you called those methods from the main method. The JRU code below shows the main method calling the real maze method. So here is main. This is similar to the main in your C program, except note this is Java. This is not C. So Java calls these functions methods. We call them functions in C. And main is calling real maze. And real maze is down here, and I'll just zoom in so you can see that a little bit. Ignore the contents of the function for the moment. Just be aware that this is the function definition, and none of this code will be executed if nobody calls this function. Now, it's being called here, so this code will run. Otherwise, the code will not run. And you can define a function in your program and never call it. Maybe you're going to use it sometime in the future. But just because code doesn't execute doesn't mean it can't be there. All right, now let's continue here. Let's talk about what a function is. Every function has 4 parts: the return type, the name, the argument list, and the body. Here is a function. It has a name called display triangle. It has a return type, just like main had a return type of integer. Display triangle has a return type, but it's void. Void means nothing. Doesn't mean 0. It means just nothing. It's like Seinfeld. It's a show about nothing. Seinfeld was a show about void. So that means that this function does not return a value or a result to the function that calls it. The argument list is here, and it's empty. The argument list is denoted by these 2 parentheses. You can put arguments in here. At the moment, there are none. We'll talk about that later. And then the body begins on 8, ends on 10. Body begins with an open curly brace, ends with a closed curly brace. In your code, to display the triangle goes here. Same is true for display square. Now, the other aspect, so we talked about name, type, name, list, and body. And the crucial point is you need to call these functions for this code to execute. We also call that invoking. So main is going to invoke these 2 functions a number of times in order to display the shape a number of times. So in the example below, here's another example of a program that includes a function, and main is calling that function. So this is very similar to exercise 1, except we put the code into a function. So this is the call. This is the definition. This is the name, argument list, return type, and the body from 4 to 6. So, and that's all explained here, what the various parts are in this display. or in this program. And I think that's it for now. That's what we covered in class. If there are any questions, please ask on the uh, WhatsApp, the Google Hangout, or if it's something more personal, then just send me an email. And lastly, it's time for comic relief. And do you know kids like this? This is one of Gary Larson's, one of my favorite cartoons by Gary Larson, Middale School for the Gifted. Okay, kids, see you on Tuesday. That's it for now. Bye.